Hello, let's do stoichiometry and let's do solutions. Couple of definitions of some terms that we're going to use first. The liquid in which we dissolve substances into is called the solvent. Now 99% of the time that's going to be water. Well, 100% of the time for us it's going to be water. But there's a whole lot of other substances that you could dissolve things into, and they would still be referred to as the solvent. Whereas the dissolved substance is called the solute. So if you're dissolving sugar into water, the solute is the sugar and the solvent is the water. Now, we need to be able to calculate the concentrations of solutions because not all solutions are the same. And so we need to be able to work out if it's a strong solution or a weak solution. And what do we mean by that in chemistry? Well, most commonly we use the term molar concentration or molarity. You often hear of solutions being called have a certain molarity, like a 5 mole molarity. And this is because the amount of the solute is in moles and it's represented per litre. Doesn't have to be a litre that we're measuring out or we're using, but it's per litre is what this means. And the symbol for concentration in our chemistry formulas is C, little c, and the measurement that we use for molar concentration is moles per litre, and it can be written shorthand as this, MOL, capital L minus 1, or just as a capital M. So you might write something like, let's see if my pen works. You may have noticed that we've been using some chemicals, particularly the acids. It might be written as 5M on the label, and that means it's 5 mole concentration, or 5 moles per litre, or the concentration is 5 mole. That's just the way we talk about it, okay? So you could have 0.25 mole or 10 mole. Therefore, a 1.5 mole solution has a concentration of 1.5 moles per litre. So if we had a litre of this, we would therefore have 1.5 moles of whatever we've dissolved into that solvent. This mouse is playing up. So 1 mole of solute, so that's the solid. So let's say it's salt, NaCl. If we weighed out 1 mole of NaCl and we dissolved it in 1 litre of water, the concentration would be 1 mole per litre, because there is actually 1 mole of the substance in 1 litre. Hopefully that makes sense. Now we could weigh out half a mole, and if we dissolve that into a litre, it would be less concentrated, wouldn't it? And therefore we would say it's 0.5 of a mole. And if we put half a mole of the solute, so sodium chloride, imagine, into half a litre, we'd get a concentration of 1 mole. It would be the same concentration as if we put 1 mole into 1 litre. Think in terms of cordial as well. If you put a certain amount of cordial and mix it with water, you get a concentration. If you halve that amount of cordial and halve that amount of water, you get the same concentration of cordial. One way of thinking about it. Molar concentration is defined by some formulas that we're going to use. Come on, old laptop, here we go. And the one that we have on our information sheet is little c equals little n divided by v, where n is the amount of substance in moles, which we used before. C is a new term, the concentration in moles per litre, and v is the volume in litres. Now, that was interesting. I thought something was supposed to appear there. Maybe not. So let's just look at an example of how we would make a very accurate liquid of known concentration. And so this would be the preparation of a solution where we have a known concentration. And we use these in chemistry quite a lot for a variety of things. They're sometimes referred to as a stock solution, because once they're made up and labelled, you can then use it whenever you need that concentration of that particular chemical. And if you ever visit a chemistry laboratory, a working one, you'll find shelves and shelves full of these stock solutions that have been very carefully made up. It's not just a matter of mixing something up and something up, it's got to be fairly accurate within most chemistry laboratories. So this is how you do it. To make a 0.5 mole per litre solution, so that's what we want a half mole solution. We add half a mole of the solvent, so we weigh it out on a piece of weighing paper. How much do we weigh out? Well, we should be able to work that out from the formula and using the molar mass. We put some of the water. Now this is called a volumetric flask, and it's specifically designed to hold a litre, but as you get closer and closer to the litre, the neck gets narrower and narrower, and therefore when you're measuring it out, using it to measure out, it gets more accurate. And I'll bring one of these into the class and I'll show you how we use it. So you have some water in here already, you pour in your half mole and then you fill it up, and there should be a little mark on the volumetric flask that perfectly measures 1 litre, and you bring it so that the meniscus is just hovering on that mark. So if we looked at it, like this would be the funnel and this would be the mark that's been very carefully put on this glassware, and we would bring the liquid up so that the meniscus just touches that line like that. And so because of course of the surface tension in water, it goes up the sides a little bit, and so this mark on the volumetric flask is specifically designed to take into consideration the meniscus, because it's not a nice flat surface. And then once we filled it up, we know that this is exactly a 0.5 mole solution, or a stock solution of 0.5 mole of whatever we dissolved. And that's how it's done. Right. When you're ready. When you're ready. So let's do a couple of calculations using those formulas. First one is preparing a solution of known concentration and volume. Calculate the number of moles of sodium chloride needed to prepare 500 milliliters of a 0.08 moles per litre salt solution. What mass of sodium chloride would be weighed out? So we're given some information. First step is work out what we are given and put them into the correct units. We're given the volume, 500 milliliters, but we need to convert that to litres to use it in our formula. And we're given the concentration, and that's already in the correct units. So we have capital V and we have C, and we're actually asked to find little m. But to get to little m, we need to work out how many moles has been dissolved in this. And that's where we work out little n using the formula n equals C times V, which is just a rearrangement of the formula on your information sheet. Put the numbers in, do the calculations, and because it's n, it's in moles. So we want 0.04 of a mole, and therefore if we know the molar mass is 58.5, using our other formula, this is capital M on our formula sheet, we can work out that we actually only need to weigh out 2.34 grams to get that solution. Have a go at these questions here. They're a little bit more complicated in that we're talking about hydrated copper sulfate, and so we have to factor in when we weigh it out, we have to factor in the water. So that just makes your molar mass a little bit different from just copper sulfate or copper 2 sulfate. But once you've done that, it shouldn't be any problem. And you've got different volumes you're making up. So again, a little bit of practice, a little bit repetitive, but you need to be able to do this for when we do mass concentration stoichiometry. Now in the next video we'll look at the working out, or what we mean by the concentration of ions in solution. Bye.